In this video, we'll introduce discussing about linear equations and determining whether or not an equation is linear or not. So let's begin by looking at the graph. So if we're looking at a linear function, if we break down that word, we can see the word line in it. So linear means that when I have a graph, it's going to form a straight line, one way or the other. And if we look at nonlinear, well, basically that means it's going to not form a straight line. So if we have our axis, there's lots of options, but we could have something that looks sort of like this. This would be not a straight line, therefore nonlinear. So the graphs are pretty easy to see. You can tell whether or not something has a straight line or not. Now, something that's worth noting on linear functions is that they have a constant rate of change, meaning that x and y are always changing at the same amount. So if like my x is changing by 3, y always changes by 2. Always, always, always. If we look at a nonlinear, well, there's a big difference between two different points, possibly. So I'm not guaranteed that constant rate of change. If we're looking at t-charts, and this kind of ties back to the constant rate of change. So if we have x and y, and let's say we've got 2, 4, 3, 6. Well, if we're looking at this, x is always adding 1, y is always adding 2, and that pattern holds true. That ratio is always the same, which means that this one is linear. It has a constant rate of change. If we're looking at perhaps something more like this, where, okay, first off, we add 1 to the x, then we add 1 to the y, and then it's plus 3, and then plus 5. This would be nonlinear. This rate of change is not constant throughout. And finally, if we look at equations. So if we're looking at a linear equation, there's two possibilities. Either we'll have y equals mx, where m is a number, or we'll have y equals mx plus b, where m and b are both numbers. Now the important thing to note here is that there is no power on x, or I guess if there is a power, it's 1. If we're looking at nonlinear functions, an example of this would be y equals x squared. Notice it has a power that's not 1. So we could also deduce y equals x cubed is nonlinear, so on and so forth.